Alright, so going over those problems from the problem set. So these first two are pretty simple because remember, it's just sine or cos, so this one's just sine of a constant times the variable. So remember, this is really simple. I'm just taking the antiderivative of the trig function, so antiderivative of sine is cos, or sorry, it's negative cos. And this will be 5x. And then I have to multiply in front. I'm just going to move this negative over. I have to multiply in front by the reciprocal of my constant. So negative 1/5. Sorry, not constant, coefficient. So I have to multiply in front by the reciprocal of my coefficient. So I'll have negative 1/5 cos 5x. Now, for cos x over 3, remember this is the same thing as the integral of cos 1/3 x dx. So again, taking the antiderivative of cos, which is sine, I can see it's just a coefficient and a variable, so I'm keeping that the same here and multiplying by the reciprocal of my coefficient, so multiplying by 3 there and saying plus c. So 3 sine 1/3 x plus c. Alright, this next one here. So, I see I have a radical and I have an expression underneath of it, and I have this expression outside. So I know that this expression underneath my radical is going to be my u. Because it's like my expression in parentheses. If it's in parentheses, it's automatically. So my u is going to be cosine 6x. So my du, my derivative of u, we're going to have to use chain rule, and we'll get negative 6, derivative of cosine, because the derivative of cosine is negative sine, so negative 6 sine 6x dx. So I don't have a negative or a 6, so multiplying by negative 6 inside the integral, negative 1/6 outside the integral. And when I rewrite it, I'll have negative 1/6 integral. Here, this square root of the cos 6x just becomes square root of u. And this negative 6 sine 6x and dx all disappear and become du. So remember, this is the same thing as if you had a u to the 1/2. So when I take the integral, I'm just adding 2/2. And I'll keep this negative 1/6 on the outside. I added 2/2, so I'll have u to the 3/2. So I added 1 to my exponent. Now I'm multiplying by the reciprocal, so multiplying by 2/3. and the du goes away, and I have plus c instead. So this, multiply that, and it'll be -1 over 9. My u, I'm going to substitute back in, so it'll be cos 6x to the 3 over 2 plus c. All right. This guy here, again, I know cosine, the two expressions multiplying together. I see cosine's the derivative of sine. I also know sine's in parentheses because sine is cubed. So my u equals sine (3x) and my du equals, my derivative of this will be 3 cos 3x. So when I take the antiderivative, I'm going to get the antiderivative of, sorry, before I do that, I don't have a 3 on the outside here, putting a 3 there, 1/3 there. So 1/3 times the antiderivative of u cubed, and the 3 cos 3x and dx go away and become du. So take the antiderivative here, I add 1 to my exponent, and I'll get 1/3 u to the 4th, multiply by the reciprocal, which is 1/4, times, then it'll become plus c. So 1/12, and my u, which was going to be sine to the 4th of 3x plus c. All right. All right, this one's pretty quick because we just see it's a coefficient times a variable. So that becomes just, we take the antiderivative of e, which is just e, keep my exponent the same, and then I'm going to multiply multiplying by the reciprocal of the coefficient, which is 1/6. I'm going to say plus c. So this next one, I have cos x times e to the sine x. So it's no longer this simple e to a coefficient times a variable. So I now have an actual expression in my variable. So I'm going to use u substitution here. u equals sine x, and I'm going to say du equals derivative of sine, which is cos x dx. So pretty easy, use substitution here. And all I'm doing, integral e to the u du. Integral of e is just itself, so it's e to the u plus c, which is just going to be e to the sine x plus c. See if I can squeeze 2 more in this video. No, I'm going to pause here and make one more video for these.